Hi, welcome back to Cracking the Cryptic. We're back on Sudoku today. There's a couple of videos upcoming I can tell you about, one of which is a beautiful solve that Mark's done of a puzzle from gmpuzzles.com, which is Thomas Snyder's website. Well worth a visit if you haven't been there before. Thomas is the, I think, 3-time World Sudoku champion and a fabulous puzzle setter. And Mark's going to be showcasing their favourite puzzle from 2018. Also, I have got a sort of magnum opus of a puzzle we got sent and requested, which turned out to be an awful lot harder than I was expecting. Ran over half an hour, that video, so yeah, I'm sorry about that. I wasn't clever enough to do it more quickly. This one I'm hoping won't be that dramatically difficult because I have a hint. This one's been sent in by somebody who said that they needed, or they apparently, a solver they looked at said they needed swordfishes to crack it, and they don't understand swordfishes, so they've asked us to have a look at it and see if we can explain to them what's going on. So I have a big hint that I'm going to be looking for swordfishes here, and I'm hoping that will help me get it done in not too long. So do pause the video, do have a go at the puzzle yourselves before you watch the solve. I always think that's the best way to learn. And I'll kick off now. Now, as usual, I'll start with just basic technique, by which I mean in any 3x3 block, if I can lock a number into just 2 positions in the block, you see 6s here because of this 6 and this 6, then I will pencil mark little 6s like this, just to remind me of the fact. And in fact, here we have a 9 and a 9 as well, operating in the same way on this block, and that gives us a 6-9 pair immediately, which is potentially quite nice. Now 4s, 4 here, and this 4, they operate on this block. There's got to be a 4 in that square. Let's put that in. 2s, I'm just noticing there's a weird sort of 7, 8, 9 thing going along these diagonals. Well, I'm not sure what that means, but we'll come back to it. 2s here, so that means I can pencil mark 2s into those 2 squares. I can pencil mark 9s here because of this 9 and this 9. That means I get some 9s over there, look. This has to be a 6 because of the 6 here, the 6 here, and this 6. I can put the 6 in. And that means this has got to be a 4. We have a 4 here and a 4 here. So let's pencil mark 4s up at the top, pencil mark 4s over there. We can pencil mark some 6s into those 2 squares because of the 6 here and the 6 here. And not many 5s in the grid, although we can pencil mark some 5s there and here. No 1s at all in the grid. Okay. So, how can we make the next bit of progress at this point? That is the question. 6s, 9s, 2s. Yes, I can see how to put another number in. Really nice piece of logic here. So we have to use the interaction of this 6 and this 6 on their respective columns. So you can see that means that the 6 in this 3x3 block, I can't pencil mark it, but effectively it's in one of those 3 positions. So it's in row 5 and row 6. I don't know which of these rows it's in, I don't know which cell it's in, but I know it's definitely in either row 5 or row 6. Now look here at this 6. That has the same effect on this 3x3 block. It's going to lock the 6 in this 3x3 block into either row 5 or row 6. So we can easily see, I hope you can see anyway, that however these 6s arrange themselves, there can't be any more 6s. In this 3x3 block we cannot have 6s in row 5 or row 6, because if we do, if we try and put a 6, for example, here, what will happen Well, we know there'll be a 6 in one of these two squares, and there'll be a 6 in one of these two squares, so we'll get a repeated 6 in the row. So all of that is really rather nice, because it means that over in this block we can't have a 6 in row 5 or row 6, so the 6 is shifted into row 4. We have a 6 here and a 6 here as well, so in fact the 6 is now locked into this square, which is lovely. I'm sure it's going to do, oh yes, it gives us a 9 as well. 9 is the only place up here in this 3x3 block that a 9 can now fit, because of the 9, this 9 over on this side. This 9 resolves the earlier 6-9 pair in this 3x3 block now, so we've got 9 here, 6 here, and that gives us a 6 here as well. Again, it's that simple Sudoku. So now we know the 6 is in one of those two positions and one of these two positions. So we've made a nice start actually. No swordfishes yet. But there's something fairly obvious going on now in row 1 and row 2 of the grid. Now, I'm helped here because I know I'm looking for a swordfish, so I'm sort of on high alert for that. But I looked at this 3 and its impact on this block. Now, the interesting thing about the 3 is that it has a pretty profound effect. This 3 here and this 3 here have a profound effect on where 3s can go in the first 2 rows of the grid. So let me highlight this. We can have 3s in those 2 positions in the first 2 rows. Obviously neither of these is good because of this 3. We can have 3s in these 2 positions. Now this 3 here prevents there from being a 3 in this square, so the only other 2 positions in rows 1 and rows 2 where a 3 can go are in these 2 squares. So here we have the foundations of a swordfish. We haven't got the swordfish yet, but certainly this sort of pattern should be making you think, wow, I need to check whether or not I have another row where the 3s are restricted to just column 3, column 6 and column 9. And we can immediately see, if we look at row 4, the 3 can only go. These are the 3 open positions, so the 3 can only go in these 3 things. You can say I can rule out the 3 from here, and you're right, but to demonstrate the swordfish, the critical thing is that we have limited the 3 in these 3 rows to exactly 3 columns. Now, you may say, well, why does that matter? I don't understand. Well, let me try and build it up. So firstly, I'm going to take out these 3s, and I want us to just focus on these 4 3s here, and imagine that we're just focusing on these 2 3x3 blocks. And it's very similar logic to what we did with the 6s down here. But hopefully you can see that if these were the only positions that 3s could go in these 2 3x3 blocks, then we have a sort of forced arrangement, because if in the final solution this was the real 3, then the implication of this being the real 3 would be that this was the real 3 in this 3x3 block. Similarly, if this turned out to be the real 3, this would be the real 3 in this 3x3 block. Now, you may say, well, why does that matter? Well, it matters because however we've arranged these 3s in the final solution, you can see they form an X pattern. If we're just drawing them up like this, I'll do some highlighting afterwards. It should be clear to everybody that there could not be any more 3s in column 3 or column 6, because we're definitely going to have a 3 either way round in column 3 and column 6. We just don't know which row they're in, but there couldn't, for example, be a 3 here. Now this is an X-wing. Now all a swordfish is we're just increasing the number of rows and columns by 1 more. So we add 1 more row, 1 more column, like this. And now let's think about this arrangement of 3s. And hopefully it'll be clear that the same sort of principle arises. So if, for example, this was the real 3 in the final solution, then we would be removing these 2 3s like this. And here, again, we have an X-swing on 3s. So if this turned out to be a 3, then this would be a 3. Obviously, if this is the real 3, I can remove these 3s from the column as well. So we have an X-swing on 3s here. Same principle with the X-swing, that would rule out 3s down column 6 and column 9. Obviously this 3 here rules out 3s down column 3 as well. So however we arrange the 3s in this pattern, we can say with certainty there are no 3s down the rest of column 3, column 6 or column 9. Now that I'm expecting to be helpful, especially because I know a swordfish is used to crack the puzzle. So how can we use that in this case? Now the way to use it is to think about which cells, which cells does this give us extra information for? So which cells are affected by the fact that there is no 3 in them anymore when there might have been in the first place? And the answer to that is, well, let's focus firstly on column 9, just because I'm here and I was looking at this 3. So clearly this position and this position are not really affected by the swordfish because we already had a 3 eliminating these 2 positions. This square, we can say with certainty we could not have ruled out a 3 from this square unless we'd spotted the swordfish. So I'm going to take a look at this square and see whether or not it matters. So we can have 1 is possible, 2 is not possible, 3 is not possible because of the swordfish, 4 looks like it's possible, 5 is not, 6 is not, 7 is not either actually, because look, actually there's a 2-7 pair here, there's a 7 here and a 7 here, so there's a 2-7 pair there, so 7 is not possible here, 8 is not possible, and 9 is not possible. So this square is a 1 or a 4. Okay, well I was hoping I would get it down to actually just one number. Maybe I'm missing a way of eliminating. I'm expecting if I can eliminate a number, it'll be the 4, not the 1, because the 1 is so, we still haven't managed to place any 1s at all in the grid. What is the next step? Okay, no, it's more obvious than I was expecting, I think. Yeah, so the effect of there being a 3 in one of these 3 positions is that we can scan down and say there's no 3 in either of these 2 squares. Therefore, the 3 in this 3x3 block is locked into one of these 2 positions, and look, we have a 3 here. Oops. So in fact, this square, that's got to be a 3. And that's not giving us much extra. That gives us 3 pencil marks here. It means the remaining cells in this 3x3 have to be 1, 2 and 5. But that's also not particularly helpful. Okay, so we're going to have to think harder. Let's remove that 3, that was confusing me. So 1, 5, 8. Just going to pencil mark some doubles in, so you can see I've diverted slightly from standard technique here, just to label cells that can only contain 2 digits, just to see if that allows me to spot anything else. 5, 8. Let's just think about whether there's any other cells affected by the swordfish. So this cell is affected by the swordfish as well, because this cell isn't, because we already had a 3. So let's check this cell as well. This cell can be 1 obviously. Now pencil mark 2's here. Oh yeah, we've got a 2-7 pair, so this can't be a 2. Can't be a 3 because of the swordfish. Can't be a 4. Can be a 5. Can't be a 6, 7, 8 or 9. So this is, aha, there we go. So there is a 1-5 pair in row 5 of the grid. And we'd identified this square as being a 1 or a 4. So now this square cannot be a 1. So having said that we were going to be able to eliminate the 4 if anything, I've now proved myself to be an idiot, and actually it's the 1 we can remove. This has to be a 4. That means this is a 4 from our earlier pencil marks. 4, 4. And now there's a hidden single. If we look at row 7 of the grid, see if you can spot it. And we still need to place a 9 in row 7. Where can we do that? Well, we can't place it here because of the 9. We can place it here. Can't place it here because of this 9, here because of this 9, or here because of this 9. So there's only one place left for a 9, and that's there. Now, that allows us to pencil mark some 9s over there, look. And now we're on the hunt for another number. So just to go through what I'm thinking about here, I'm trying to do what we all do when we solve Sudoku. So I'm looking at the grid and comparing rows and columns. And I'm trying to see or spot weak areas. So I'm looking for cells that are going to contain relatively few digits. So this one looks to me to be interesting because, well, what can it be? It can be a 1. It can't be a 2, 3, 4, 5, 6. Can it be a 7? Below. It can be a 7. Can't be an 8 and can't be a 9. So this square here is a 1 or a 7. This square is also restricted. How this can be a 1. Can't be a 2. Can't be a 3, 4, or 5, or 6. Can be a 7. Can it be an 8? I think it can be an 8. Okay, so that's not quite as good as I was hoping for. Aha! Yes, but what we can do, we can go back to can we? I was looking at this 8 here, and I noticed that that's locking. That locks the 8 in row 1 of the grid into the same positions that we had the 3s, except this 8 here isn't so useful. Let's just check though, because this row, again, this is probably the second swordfish, because let's think about where we can place 8s in this grid now. So I'm going to have a look firstly at row 1. It can be here, here, can't be here, but I'm going to label as if it could just to demonstrate the swordfish. Remember, with the swordfish we're looking for 3 rows and 3 columns. It doesn't matter if we only have if we have 2 rows and 3 columns or 3 rows and 2 columns, that's still absolutely fine. The same logic will apply. But now you can see if we look at row 4 of the grid, the 8s can only go in these 3 squares. In fact, this one we don't even need, but we have this mirroring. And yes, there it is. It there? 8, 8. Yes. Okay, so let's look at row 7. Where can an 8 go? Well, it can't go here, but I'm going to label it just for the sake of argument. It can't go here, it can go here, and it can go here. So there is a swordfish on 8 now. I'll do the highlighting at the end. Now if I was to tidy up the swordfish, we'd remove the 8 from this square, we could remove this 8 from this square, and then we're all good. And so this is the actual pattern of the swordfish, but this has the same effect. It's a swordfish on the rows, i.e. we've locked these 8s into the same columns within 3 different rows, and therefore looking down these columns we can remove 8 from any skull that is not in the swordfish. So that the reason I was looking at 8s was this square here. I noticed if I could remove the 8 from this square I get a 1-7 pair, and I'm hoping that'll be useful. So we can remove this 8. Now the 1-7 pair, now what can we do with that? Well, one thing we can do, which is nice, is if we look at this square, we have a 1-5 pair already in row 5 of the grid. So this square cannot contain a 1. Now we know neither of these two squares contain a 1 either. So although there are hardly any 1s in the grid, in fact we still haven't placed any 1s at all in the grid, I now know that the 1 in the central 3x3 block is locked into one of these two positions. That means that the 1 in this 3x3 block is locked into one of these two positions. Oh, this is, that's beautiful. I'm sure you've all spotted it as well, but it's really lovely the way this has worked out. So now these 1s here have a great effect on this 3x3 block. They lock the 1s into one of these 4 squares. And again we can do this little trick where we've locked the 1s now in this 3x3 block into column 2 and column 3. Don't know where they go, okay, but I know they're definitely in column 2 or column 3. Now look down here. Again, I have no idea where the 1 goes in this 3x3 block, except it is definitely in column 2 or column 3. So overall, I know now that I can't have any more 1s in this puzzle in column 2 or column 3. So let's have a look at the effect on this block. So this square here can no longer contain a 1. So it's going to have to be an 8. Now I'm going to have to just be a bit careful because I can't remember whether I've which ones are pencil marks and which ones are sort of swordfish markings. But this 8 here looks very nice straight away, doesn't it? Because we have 8 here, 8 here. So this must, oh no. Just look at the mouse. This is going to have to be an 8. That means this is an 8 up here. Means this is an 8 down here. That means this is an 8. Now this square here can only be a 1 or a 3, I think, but you can see we're able to eliminate the 1 because we have the 1-7 pair. So this must be a 3, therefore this must be a 1, and we finally, after all this, managed to place our first 1 in the grid. Now just coming back over here, you can see this square here could only be, is it a 1 or a 5? And we have the 1s here, so this square here is going to have to be a 5. And that's going to be a 1 as well, so we've got a second 1 in the grid. 5, 5, 5. This is a 5. 5, 5. Okay, 2, 7. 3, 6, 9 into these squares. 9, 3, 6. Again, I'm almost certainly going to get confused here with the interaction of swordfish markings and standard pencil mark notation, so I'm going to have to play this a bit slowly, I think. If you don't want to watch, I don't blame you, because I think the puzzle is basically solved. This, I need to place a 3 here, so that's it. 3, 6, 2, like that. Okay, so thanks very much for watching. I hope you enjoyed that solve. I thought this was a beautiful puzzle, so thanks very much to the person who sent this in. I don't mind you giving me hints, actually. In some ways I think it makes for a smoother solve. If you enjoyed the content, please subscribe to the channel. We really appreciate it. We're trying to get our subscriber numbers up at the moment, so if all of you do enjoy it, then please just tell one friend about the channel and see if you can get them to subscribe. We'd really appreciate that. Thanks for watching. Back again soon with another edition of Cracking the Cryptic.